Today, on Teardown, we have an Insignia Slimline Pico Projector, model NS-PR60. This thing came from eBay for $20 and it was a store return, had no power cable or connection cable to it, and it was totally dead, or it just doesn't work. So the first order of business is I have it connected to my adjustable power supply. This little bugger takes 9 volts, really strange voltage, so I'm betting that there are 2 lithium ion cells in here. Anyway, what I'm going to do is I am going to see if the batteries charge up. I've got a little red light here, a very tiny little red light. We're going to see if it changes colors. So far it's drawing about 0.7 amps. Looks to be charging. So let's see if it does. Let's see if it works and get inside of it. Let's see if it works after I get inside of it. While we wait for the projector to hopefully charge, let's take a look at some of its features. A 50-lumen output with long life LEDs. That's good. Projects images up to 80 inches. Alright, is that wide? Is that 80 inches away from the projector? Questions. And what happens after that? Does the image get blurry? Does it get dark? Does it vanish? I don't know. Accepts video signals up to 180p for maximum compatibility. That's not maximum compatibility if you have a limit on the video signal input. I mean, you can't take 4K, so that's not maximum compatibility, is it? Well, and it doesn't say anywhere where the native resolution is. Okay. Internal battery with up to 100-minute star runtime at 50% volume with normal brightness. Okay, why do you have a star there if you're not going to list it anywhere else on the box other than immediately after or in the same sentence? I'm pretty sure there's more than one battery in there too. Oversized speakers and amplifier provide upgraded audio. If they're oversized, how did you get them in the projector? 3.5mm stereo output for use with headphones or external audio devices. But that's what provides the upgraded audio. Threaded socket, that's just for the tripod, a standard tripod that I don't have. And power supply, which in my special case, I don't have either. Alright, let's take a look at the actual specifications here. And it looks like the native resolution is only 854 by 480, which isn't too bad, but it's definitely not that 1080p they try to get you with on the front of the box. Here's the rest of the specifications. They don't really get into detail about the battery life circumstances here, but otherwise that's definitely what we're looking at. Let's take a look at the reviews. Well, that's ironic. Huh. Good news, the red light has turned green, indicating a full charge. Yeah, you don't really see the green light either, do you? There's the green light. Let's see if this turns on. On. Oh. We have something. It's blue. We have image. Excellent. Yeah. We'll get into how it looks later on. Let's take it apart. Off. So I'm guessing there's probably screws underneath these. Yeah, let's find out. No. Not screws underneath there. Where have they hidden the screws? Nope. Oh, what's that? That feels like it could possibly be a screw. Let's find out. What? That's not a screw either. Okay. Well, that took an unexpected turn, didn't it? Does it just snap apart? Maybe that's why they don't tell you to drop it. Yeah. Brute force, maybe. Well, that got confusing real quick, didn't it? Oh, well, that is interesting. Oh. I mean, I really can't get into that. They glue it together? Oh? Oh. No way. What? There are 2 screws. Well, now that we found the screws, we can get them out. Does it slide? It feels like something that should slide. It doesn't. Oh. Getting in there. This could be quite violent. Oh. I just... Can't believe how well put this thing is together. That's a tough one. Oh. See what we have for shims. Yeah, that might work. Don't use metal shims, kids. And we're in. Well, that's a fair bit simpler than I was expecting, to be honest. You got all this room on the board. You could have had a USB or SD card reader, no problem. And there's the battery. That's yeah, definitely a 2-cell battery inside of here, just like I thought. That's gonna be the 7.4, yeah, peak charge voltage of the 8.4 volts. Pretty cool. Nice battery. Yeah, looks like we have the main IC right here, a couple of other components as well. It's probably for like power regulating and stuff, power management. Nice little fan here. Not that could be the little amplifier chip right there. Get closer to that. Yeah, that's probably the little amplifier. And Quite a lot of cables going up there. Here's your oversized speakers. One of them. Another oversized speaker. Yeah, quite oversized. Quite an oversized little amp there. That's the biggest amp I've ever seen. Let's get into the optics a little bit. So we got a heat sink here. Looks like we got the same red and blue LED combination up here, and probably the green LED in this area. So, gonna be the optical train mechanism here, isn't it? That, oh, okay. That's just a little gear ratio in there. I don't know if you can see it or not, but they actually have this whole thing geared inside there, and all it does is move that back and forth. That's kind of a necessary. Well, if it's a necessary, that's the first thing to go. It might be seated underneath the board. Got one screw here, a little screw there. Let's take off the protective little tape here. That way we can disconnect it from the board later on. Nice little high density ZIF connector right here. Bring that up a little bit. Yeah, maybe I can pull that out now. Lift that up out of the way. And that should go to the DLP. They really packed the pins on that connection, didn't they? A lot of pins. Yep, that should come up right easy now. Or not. Oh, okay. That's what's stopping it. It's the focus wheel. It's brute force time. Yeah, that's interesting. Not as interesting as this, though. Okay, and we got here the back of the DMD. Looks like the digital mirror device. Looks like one of those really long little ones. That's probably a fairly common little DMD in there. I think we'll probably be able to get this one on the microscope because there are two screws which that I can take the DMD off of, which will be really nice. Looks looks like here's the LED ribbon cable. It probably goes to the LED arrangement, and I can probably pull out the optical core. It does look like the majority of it's going to be underneath this ribbon cable. I don't know if I'm going to be able to power it up and look on the inside. Of course, it might be underneath here where the access point is, which is likely as well. I'm going to remove that little bit of Gap-Down tape on the top. And let's see about removing that optical engine. Looks like there's only 2 screws. Well, that's easy. Oh, there's got to be another screw somewhere. They do a good job on hiding them. That's got to be over in this section here. Oh, come on. There you go. Yep, another screw back there. It looks like this little cover here. Oh yeah. So it's tabbed on to the front with a little bit of glue. So you can see those 2 points. There's a little tab point right here, and there's another little tab point there, but maybe you can flip that cover up, see what's in there. Looks like there's a couple of screws here too that might be holding it on. Let's see. I don't think it wants to come off. It looks like there's a little screw here too. Ah, yeah, okay. Looks like there's a little metal shield that this is part of. Okay, I see it. Let's extract the optical engine now. All the screws. Oh, I didn't even take that screw out, didn't I? Got too busy talking. Smaller screwdriver. Ooh, that's a messed up nail. That's okay. They grew back, and for free. All right. Now it's free. Oh yeah, it really does look like this whole area here is going to be the access to seeing the optical core while it's running. So I'll probably have to figure out a way of flipping this board over to get a video of the other side as it runs. Yeah. Now let's attempt that. I don't know. I kind of want to pull that board. I think I'm going to pull that board. Oh, yeah, we're not using that screwdriver. Gotta pull the fan and that oversized pair of speakers out. They're so big that they're getting in the way. Two more screws. Looks clear. That's nice. So yeah, it looks like we have a lot of the power regulation here. We got a lot of the ceramic capacitors, some of the inductors, and what looks like to be two battery charge systems. Little fuse here. That's nice. So I thought that was an optical encoder of some sort, but that's just for the little LEDs right there. So yeah, the green and the red battery indicator LEDs right there. More power components in this area. Little custom chip right there. I'll post up high definition pictures of the board in the video at the end if you want to take a look at this in more detail. I don't really know what's underneath this shielded lid. Is it a removable kind? Yeah, it does look removable, but I'm not seeing much in there, to be honest. Yeah, not too much going on. Well, let's get into the little light engine a bit. As I said, I have my sneaking suspicion that this can be lifted up pretty easily. So I think I'm going to do that. Oh, they really did go to town on the little tape, didn't they? So these are little shielding pads that kind of make sure everything is grounded well. In case you have a lightning strike in your pocket. The little one for the DMD. It's tucked underneath there, isn't it? Yes, it is. Right. Time to get inside of there. Oh, that's nice engineering. Here's the inside of the optical system, and it looks pretty similar to the AAXA projector I took apart before. Most likely the green LED is going to be in this section here, followed by the convex lens, and in that section here is going to be the red and blue LEDs, also followed by a convex lens. We have two pieces of dichroic glass here, and they're staggered at such a way to correct for the difference of location for each one of those red and blue LEDs inside. After that, we have a single piece here, which takes the purpose of two fly eye lens arrangements. And what this does is it ensures that the light coming off the system here is kind of in even parallel rays, so that way you get a really good even coverage. After that, we have another convex lens and the reflecting mirror here in the back section. And you got an interesting section of lenses here, and they're bent in such a way where they will shoot the light up here inside of the prism and off of the DLP chip here. Then the DLP chip reflects the light back, and it hits the internal surface of the prism, and that reflection gets sent out through the focusing assembly inside here. I want to get some energy going into this thing, so I'm going to connect it up to the board again and power it up. Hopefully we can see how it looks like while it's running. Time to flip the on switch and see if it works still. Da-da-da-da. Come on. There we go. Yeah. Well, that's a cute setup. Let's see if I can turn off the light. Get us any more kind of contrast on what's going on there. And yep, definitely seems to be that same setup. We got the green LED here, and the pink, the blue and the red there. Nice. Yeah, that does look cool. It seems to have a faster refresh rate than the AAXA 2. Not as much flicker on there, no rainbowing. Very nice output. Yeah, time to go set up a microscope. Here I have set up the DMD. It's reconnected back onto the projector mainboard, and the mainboard is also connected up to the HDMI output on my computer. I have Windows Media Player running full screen, so hopefully that's what we'll see on the DMD once I turn on the device. Let's see what happens. It's a precarious setup for sure. One. Hey, that's good. Hope. Oh, that's good. That's definitely good. Nice. Oh, that's cool. I can get a better contrast on that. Oh, yeah, I can. Come on. Oh, I just had it. My viewers demand better. Yeah, move the light. Hey, I can just move the light. That's easier. Or not. God, that is so cool. A full little display running on top of a chip. Now, mind you, it is in grayscale, but man, that is awesome.
That is one of the neatest things I've ever seen. That's literally mirror flipping crazy. There's all of those little mirrors moving on the surface giving that image. Wow. That is amazing. Here on the microscope, let's see what we can see. So I am at, let's see, the lowest magnification, which is the 12x eyepiece and a 4 objective lens. Yep, okay. That looks to be the top of the DMG. Focus. Yep. And here's the DMG. Now let's turn it on. See if we can get down to those pixels. A little bit of a change there. Wow, that was really clear. Loose HDMI cable. Oh, that is cool. Let's get some focus on that. That is neat. So what you're seeing is all those little mirrors on the surface move. See if I can get a closer magnification. We'll move up to the 10 objective lens from the 4. That'll give us more magnification. Wow. You can actually see the little micro mirrors. That is amazing. That is mind-blowing to watch. Wow, I'm glad I was able to capture this on film. I've been wanting to capture a functioning DMD on camera for a while under a microscope, and this is great. Alright, I've got the projector put back together, and it looks like it's working perfectly. Let's talk about this projector. I wouldn't really recommend this projector because of 2 reasons. It's a goofy power plug. You can't use a USB. You gotta take your own little power plug with you wherever you take this. And the HDMI port. Pretty much all you can put into it. No USB, no SD card, no nothing like that.
It's pretty much a regular projector with low resolution. Yeah. So yeah, if you're gonna look for a standalone projector, don't get one of these. I mean, it looks nice. And, a couple other things with it too. The LEDs run really hot, so I don't know exactly how long they're gonna last. Yeah. How does it stack up against the other projectors that I have? Well, let's be honest. I don't really review projectors. I like to tear them down, and I want to eventually start messing around with the DLP chips, which is my end goal. So, the AAXA is a wonderful projector. It's not as bright as the Insignia, but it does have the features of the SD card and the USB and the mini HDMI here, as well as component. Plus, it can play its own videos and stuff, which is cool. You don't need anything else with this. So if you're willing to sacrifice the brightness, look at the functionality out of something like this. The Inyo, how do you pronounce that? Really, someone send me a phonetic sheet. The Smart Beam, it's for people who like something that looks cooler when it's powered off. It seems to skew the aspect ratio, not skew it, but it squeezes it. So that's not too cool. The resolution is pretty terrible, and I'm not actually going to be tearing this one apart. I have a friend who has one of these, and his battery is dead, so I'm going to be hopefully tearing his apart one day. The one other thing that I don't like about this design is, it really looks cool. I mean, you're looking at that and you're like, oh, I want that. But the problem is which one would you rather have in your pocket? Just saying. The other thing that I've done is I've made a little video that has some cool kaleidoscope, moving, colorful action, and I also put music there so we can see how each one of these sound in contrast to one another. That's about the best I can do. And after that, I'm going to have all of the high definition pictures for what's inside of this projector. So, yeah, I hope you enjoy that. Expanded audio output in a compact size. What's expanded audio even mean? Ugh, stupid box. I'm done. Stay tuned for more.